there is a dedicated module called the SimCenter Sound Intensity Testing module. First, we'll go through the workflow for that, then we'll see the live demo of that. In the sound intensity testing, like typically this is the workflow that is followed. First, you generate a geometry which is representative of the area that you are going to do the intensity measurements on. You can make a parallelepiped or any kind of irregular type of geometry you can make. So you create an acoustic mesh first, then you actually go and do the measurement. You set up an intensity probe and do the measurement. And there will be feedbacks for you to tell you when one measurement is completed, when you're going to the next one, which point you should go to, and things like that. And once you do the measurement of all the intensities at the desired location, then you go to the intensity analysis, which is where you'll do the data validation checks, and also you can visualize the result and generate acoustic maps that you can then later show as active pictures in test lab as part of the reporting. So first you generate a geometry, next you go to the testing, then you go to the analysis, and then finally you can generate the report to visualize the results. Okay, so let's take a closer look at all of them. First is the geometry mesh generation. That is the first step. You are going to generate an acoustic mesh, which is representative of the surface area over which you are going to do this intensity measurement. That can be in the form of like a parallelepiped, like shown in the bottom left-hand side here, or a hemisphere, or any kind of irregular shape. And this acoustic mesh, you will see that you can determine what is the size of the mesh that you are going to generate. Like what are the dimensions of the parallelepiped, for example, that you are going to do, how many discrete points that you are going to generate. Now, if you are using the 9614-1 standard, then you need to define this, how many number of points you want to measure on each surface, be it the front, back, right, left, top. But on the other hand, if you are using the 9614-2 standard, then for the front side, it will be like a one by one grid. So you don't need to break it down into multiple points. Okay. So once you have this acoustic mesh generated, you can also superimpose a picture of the test object on that, so that you have a clear indication of, hey, this measurement point corresponds to this point on the pulley or the gear or whatever. You can do that, and that is a really cool visualization tool to help convey results in an effective manner. So first you set up the mesh, right, the acoustic mesh. Then you go and set up the probe. So the acoustic mesh tells you where all you are going to do the measurements, and then you go to the intensity testing channel setup worksheet where you specify which channels you are going to use. In a pressure probe, like a PP probe, 2 microphones are there. So you will set up to activate 2 channels, mic A and mic B, and you will put the appropriate input mode like ICP, and then specify the sensitivity. The sensitivity can be in the form of you can read it from the TEDs or read it from the data sheet of the microphones. Most commonly, we recommend to do the calibration of each microphone. And so you do the calibration to enter the sensitivity values here. There are 2 microphones, mic A and mic B, and so you set them up here in the channel setup worksheet. Then there is the sound intensity setup worksheet where you actually declare the intensity probe. Here, I can say that, hey, I want to create a new probe, and this is a pressure probe. From this pull down, there will be a pressure velocity probe, the PV probe. The pressure probe, which is mic 1, mic 2, and then you can also determine what is the spacer distance. So this is a known value that you have to provide to the software to tell it, hey, this is the spacer I'm using, because basically make all the calculations based on that. And based on the spacer distance, theoretically, what is the frequency range that is applicable? It will show that to you. And here in the point identification, that will be the point on the geometry that you can show, hey, this is the point I'm measuring, and this is the direction in which I'm measuring. Like you can measure intensity in all 3 directions and at each of the points, X, Y, Z direction. Then to be compliant with the ISO standards, a couple of the things that are required is the phase calibration of the probe and the pressure residual intensity index measurement. And both of these are supported within test lab. So in a phase calibration, you send a known signal to both microphones. If there is a known source and the same signal is sent to both mics, we should see that the difference between the 2 mics is 0, and hence the intensity should be 0. But in real life, you will see that there is some what is called as phase mismatch between the 2 microphones. So even if you send the same known source signal, there will be some differences, and that determines what is called as a noise floor. And the noise floor is quantified in terms of this pressure residual intensity index. So to determine that, you send the same signal And then whatever is an intensity that you measure, that is the lower limit for the correct measurement. That determines the lowest intensity level that you can measure. And upper limit is actually the sound pressure that you measure. So during intensity measure, you want to make sure that your measured intensity is between this lower limit, which is determined by this pressure residual intensity index, and the upper limit, which comes from the sound pressure measurement. You can do the processing in FFT based, the frequency domain, or in the time domain based. Both options are available within the TestLab software. So what you do is, in the intensity measurement, you go through point by point wherever you want to measure. As you are measuring the data, it will give you a status indicator of where you are measuring it, and it shows in green which points have been completed and what is the next point, or what is the point that you're interested in. And then it also shows you live measured intensity, and also shows you where the intensity is with respect to the upper limit and lower limit. Here you can see the measured intensities are under the upper limit. There is a lower limit as well based on the PRII. It's a good visual indicator. So if it is showing like blue or green, that means the intensity measured is good data. If you see red, that means that in some octave bands that can happen, and that means that there is a negative intensity value. So sometimes it may so happen that your probe is not facing perpendicular to the surface, or your orientation of the mics in the probe is such that you have declared one mic to be at the front and one mic to be at the back, but you're not pointing the probe in that manner. Then you will see that all the intensities that you are measured are negative. And so that having this visual indicator helps you quickly determine whether you're getting good quality data or not. Once you measure this data, then we go through the sound intensity analysis, where you can do this visualization of the data measurements to check the data quality. And you can check whether the data is compliant with the ISO standards. The field indicators are calculated automatically. And then also you'll also be able to generate this acoustic maps to identify the hotspots and do the sound power calculations. So this intensity analysis worksheet, it is broken down into 4 areas. First is you take a look at the data, then you do the data visualization. And this is where you determine what are the calculations that you want to make on the bottom left-hand side. And the 3D visualization of the results is done on this bottom right-hand side here. So with that background, let's go into to do a demonstration in the software to see how this whole workflow works. So I have opened a sound intensity testing module, which is specifically designed for the sound intensity measurement. As per the workflow, first we go to the geometry worksheet and we'll generate this acoustic mesh geometry. So I click on generate acoustic mesh. And then here I'm saying that I want like a rectangular parallel pipette. Similarly, I can generate trapezium or any irregular shape. Here I'll just go with a single rectangular or parallel pipette. I'm saying the dimensions of the surface area that I want to measure. Now this is very important, that the dimensions that you specify here are actually the dimensions of the surface over which you are going to do the intensity measurements, because this area will be used for the calculation of the sound power. Remember, sound power is intensity times the area. With the measured intensity at each of the areas that you are going to have and multiply with the area, then you get the total sound power. And so for this rectangular or this parallel pipette, this is the dimensions that I want, like a 1 meter by 1 meter by 1 meter. I have different surfaces here, like front, back, left, right, and top. This is the top, front, left, like that. And each one is broken down into 2 by 2 measure. I'm not going to measure the bottom side, so I'm going to uncheck that. So we are going to measure it only in 5 phases, 1, 2, 3, 4, 5, front, back, right, left, and top. And 5 times 4, each surface is broken down into 2 by 2, so that is 4 points. So total there will be 20 points of measurement. You can determine which is the order in which you want to go in terms of the number increment. Like the lower left corner, I'm saying that start there and go up and down. So that is the order in which the numbers will be incremented as we go to the different phases. Click on this create button and it generates this acoustic mesh that I see. For each point, I can see here, this is the top number 1 point, top number 3, top 2, like that. And for this top surface, and similarly on this side, it will be like you can see, like this is the right side and this is the front side, and so opposite to that is the back. And for this top side, for example, I want to put a photo. So I'll go select this top surface and then go here and I will select my photo that I want to put. It's a JPEG file that I had previously taken. I'll just insert it and I can place it exactly to where I want it to be. And I can zoom in or zoom out. And then if need be, you can crop out the tool outside also, but you can make the adjustment here. So this is superimposing the picture to this acoustic mesh. I'll hit close. Once I'm done with this, I'm going to save this project and say, I'll give the name of a project. And Now I go to the channel setup to set up the channels that the two channels that I want to measure. I have two microphones, so I'll call this mic A. This is mic B, and they are not case sensitive here. It doesn't really matter. And then typically these microphones are ICP microphones in the probe, so I'm going to both the mics are ICP. And just for simplicity here, I'm going to enter this sensitivity values here, which is 12.5 millivolt per Pascal. As I said, it's better to always do the calibration before each test. So, and that is done in the calibration worksheet. In the acquisition setup worksheet, you can set up the bandwidth over which you are going to do the measurements, and you can also take a look at the signals. The sound intensity. Oh, look at that! Scott made some nice frequency noise.
That's right.
Then you go to the sound intensity setup worksheet, and here you declare what is the standard that you're going to follow, the 9614-1 or 2, and then based on that, you can do the measurements. You can create a new probe, click on this button, and here is a pull down to say whether it is pressure probe, that is 2 microphone probe, or PV probe, the pressure and velocity probe. Here for our situation, I'll do the PP probe, and so I define the probe, and see these fields are automatically filled, and I'm saying that I will use a 50 millimeter spacer, so that is filled in here. And the first point I'm going to measure, this is exactly, it is getting it from the geometry that we created. And I'm going to say I'm going to select the top point. And you can do the phase calibration or the correction, and all that can be loaded in here too. Once I have set this up, I can go to this measure worksheet, and it's ready to take some data here. We are going to do like a dummy measurement here. And it is saying that the top one, that is the point that I'm going to measure first, following which we'll go to the next point as set up in our geometry. And we have set it up such that it will automatically increment the points. And here at the bottom left-hand side, there is a status indicator, which is a good thing to always check because that gives some meaningful information. So here we are interested in the sound intensity lower limit, and we had to do the PRII measurement to be able to do that. So that's why it is giving this warning saying that we don't have this PRII measurement. So you should know that. Okay, so with that, let's go ahead and let's take some data. It's taking the top 1 point, as you can see by the marker here, and you can go. And this is the what do you call it, the live intensity in terms of the narrow band, and this is in terms of the octave band. And you can see there is a instantaneous one, and then there is the average one. The blue one is the average one. The red ones here means negative intensity. And now here is the status indicator showing that it's getting ready to take the next point, which is the top 2 point. So it's done with this top 1, which is the first geometry point. Now it is going to the top 2. Then it will go through the same measurement that we had done. And here there is an indicator, like there is that's upper limit, and you can see that the measured intensity values, intensity spectra, are within the upper limit. If we had the PRII, we could have gotten the lower limit also. Okay, so then
but I would have to physically move it to each point, even though the software is ready. I have to physically move
that is right. That is right. Yeah. That is absolutely
sometimes you have to make that.
Right. So now that's really a very good point, because you have to physically move the microphone or the probe to that point, you know. And then so now we are done with the 3. That's why they are shown in green, and then it's ready for the 4th one. So as you can see, there is a really excellent visual indicators to tell you which point you are at, what is the next point you are going to measure, and then there is a live display of the intensity spectrum to really give an assessment, even while you're taking the data, what type of data you're getting. And you can see how simple it was to set up and get started to take the data.